Good day guys, welcome to Calcumind once again. And today we'll be looking at past question 2023-2024 on binomial distribution. So this problem, it states that if the probability of success is 1 over 10, how many trials are necessary so that the probability of at least one success is greater than 1 over 2? So this is a binomial distribution formula. I'll be using the formula whereby n c of x, p of x, 1 minus p n minus x is equal to the probability of the success x. So now we'll be using this formula to work out this equation. If you have now watched our video on binomial distribution, you can go back and check other videos in order to get a better understanding. So let's dive right into the equation. So let's write out our first statement. The probability of at least the probability of at least one success should be greater than 1 over 2. We are reading the question, at least one success is greater than 1 over 2. So now, let's write that out in normal inequality sign. Say the probability of one success, the x, should be at least 1, should be greater than 1 or equal to 1, should be greater than 1 over 2. So now, if they say at least one success, using the complement law, whereby instead of saying the probability of head is equal to 1 over 2, you can say the probability of head is equal to 1 minus the probability of tail. So now, for this equation, we can say instead of the probability of at least one success, we can say 1 minus the probability of no success, which is x equals to 0. That means that is the number of success. We don't want any success. So using complement law, instead of x is at least one success, we'll do p x greater than 1 is equal to 1 minus p x equals to 0. So we are using the complement of this to work out here. And now we are going to be replacing this into the equation. That is what we are going to be doing. So this 1 minus p x equals to 0 is greater than 1 over 2. So now we want 0 successes. We'll then be using this our equation, the binomial equation earlier that we worked on, to be working for x equals to 0. We'll be working on x equals to 0. So using this equation, we'll be working on x equals to 0. So the probability that x is equal to 0, whereby our number of trial n, that is what we are tasked to find. How many number of trial are necessary? So we are being tasked to find the number of trial. So this n x, our x value is 0. So this will write 0 multiplied by the probability. From our equation, the probability of success p is equal to 1 over 10. So this 1 over 10 multiplied by x. From this thing, we can see that let's write out the equation properly. Px is equal to ncx p of x 1 minus p n minus x. So now this 1 minus 1 over 10 n minus 0, whereby our x, from this we can see that our x is 0. So we are just basically substituting all our values. So now let's work this out. This p of x equal to 0 is equal to n factorial, using the factorial symbol formula, n minus 0 factorial, 0 factorial. So 1 raised to power, okay, there is an x here. X is 0. So 1 over 10 raised to power 0. Anything raised to power 0 is 1. So this is 1. This is 1. 1 minus 1 over 10 is 9 over 10. So this n minus 0 is still n. So we are going to be working this out. N minus 0 from this equation, we can see n minus 0 is n. So this n factorial divided by n factorial. 0 factorial, we should note that 0 factorial is always 1. So this 1, 9 over 10 raised to power n. So n factorial from here will cancel n factorial. So this 1 multiplied by 1, n over 10 raised to power n. So p of x equals to 0. Equals to 0 is equal to n over 10 raised to power n. 9 over 10 raised to power n. So now, we have gotten our value. Just think of it that this is the value. If we get the value of n, we'll be able to work out the probability that we have 0 successes. So just think of it as our value. We are going to be imputing it into this equation, 1 minus p of x. So now it's going to be 1 minus p of x. P that x equals to 0 is 1 minus is greater than 1 over 2. You see, the equations are coming to life. Just think of this as an equal to, but it's a greater than sign. So we are going to be making n the subject of the formula from this equation. So now, we'll make n the subject of the formula from this point. So taking this 1 over to this other side, we'll be having minus 9 over 10 raised to power n is 1 over 2 minus 1. So if we work this out, 1 over 2 minus 1 is minus 1 over 2. So this minus 9 over 10 n. So we are going to be multiplying both sides. Multiply this point by minus. Multiply here by minus so we can eliminate the minus on both sides. So let's do that. Minus times minus is plus. So this 9 over 10 greater than minus times minus is plus. Or you can just choose to divide both sides by minus. So it will cancel out the minus. So now let's make n the subject of the formula from this point. We'll be taking log of both sides. Taking log of both sides. You'll be asking, why are we taking log of both sides? We have an exponent here, and we want it to be at the side so we can divide all through. If we use the formula log A over B, it's the same thing as B log A. And if you then equate all to like x, if we divide through by log A, we have gotten our B standing alone. So that is the idea we are working with now. So we'll take log of here. This log 9 over 10, if you break it down, is 0.9 raised to power n is greater than 1 over 2. So this, using our laws of indices, it will be n log 0.9. You can see what we did here. We took this, moved it over to the side. So that is the idea we are working with. It's greater than 0.5. So now, we'll be dividing through by log 0.9 to make n the subject of the formula. So n, okay, we didn't do this. We did not take the log of this side. So this log 0.5. So this is n log 0.5 divided all through by log 0.9. So you can see we have been able to make n the subject of the formula from this point by taking the log of both sides. So if we work this out, and log 0.5 divided by log 0.9, if we work that out, we'll be getting 6.57. And for number of trials, they are mostly integers. They don't include floats, which are decimal points. So we just simply round this up to the nearest figure. So if we round this up, taking the 5, turning it into a 1 and adding it to this, is going to be 7. So the number of trials, we can subsequently conclude that the number of trials that we need for x to be at least one success, to be greater than 1/2, is 7 trials. Thank you for watching the video. Make sure to like, share, and comment. Thank you.